Good morning, friends. Today we will be going through problem of Geeks for Geeks daily problem. Problem of the day: Equalize the towers. The problem statement contains: you are given an array heights representing the height of the towers and another array cost, where each element represents the cost of modifying the height of respective tower. The goal is to make all towers of same height by either adding or removing blocks from each tower. Modifying the height of tower, that is I can add or remove I by 1 unit cost of I. Return the minimum cost to equalize the heights of all the towers. Here we are given with the example, my heights are 1, 2 and 3, and the cost for changing each of the tower height by 1 unit is 10, 100 and 1000. Suppose the question says that I have the height 1, 2 and 3 and the cost of changing each 1 unit is 10, 100 and 1000. Now one thing I can do is, suppose I want to change all the heights to 1. How much does it cost for me? I need to decrease this by 2 units. So it will be 2 into 1000. 2000 plus I need to decrease it by 1 unit. So it will be 100. 1 into 100, 100. So this will cost me 2100. If I want to change all the heights to 1, then it will cost me 2100. If I want to change all heights to 2, then how much it would cost me? I need to increase the first 1 by 1 unit, so it will cost me 10, and I need to keep the second one in the same because I want 2 as the height, and for 3 I need to decrease it by 1 unit, so it will cost me 1000, which is 1010 total cost. Now if I want to change all the heights to 3, then what I can say, it will cost me, for first it will cost me 2 units, which is 2 into 10, 20, and for second it will cost me 1 unit to go to 3, so it will be 100. So in final it cost me 120. Out of all these 3, I can say that 120 is the least. You can ask me, why can't I change the height to 4 units? Suppose 4 or 5. If I pick 5, then I need to change this by 4 units. That cost me 40. I need to change this by 3 units, increase it by 3 units, that cost me 300, and I also need to increase the third one by 2 units, that cost me 2000. So it will cost me 2000 plus 300 plus 40, 2340 unit, 40 total cost. So you can say that, okay, now we can say that whatever may be, I'll be sticking to one of the heights in my available thing, and I'll be converting rest of the towers to that height. So that is the optimal thing. Now how can I do it? Suppose think it of in this way. If I know at any particular position, if I know what it is costing me from extreme left till that point, what is the total cost that is being what is the total cost for changing all the heights from extreme left to till that index. If I know that value, suppose that is value L, and if I also know that what is the cost for changing all the towers which are on my right side, if I know that cost, that is R, then I can say that L plus R is my total cost to achieve that particular height. Okay, which is nothing but, suppose I have the towers T1, T2, T3, T4, T5, T6, T7, and now suppose I am at index T3. Now if I know that uh, from changing heights of T1 and T2 to T3, and I am changing all the heights of T7, T6, T5 and T4 to T3. Now if this cost of changing heights from T7, T6, T5 and T4 to T3 is suppose R, and if it is costing me to change the heights of T1 and T2 is costing me is L, then if I am at this particular index I, then I can say that L plus R will be my total cost of converting all the other towers to the tower T3 to tower T3. So how can I achieve it? One way I can achieve it, I'll be going from starting from left to right, and I'll be adding the tower heights and some at each of the tower, and I'll be storing this in an array. Similarly, I'll be coming from right to left, and I'll be doing the same thing from right to left. I'll be storing that in an array, and every time when I'm at a particular index, I'll be handling that. I'll be summing up the value. Now we will code this thing. Given the heights, and one more thing is, for achieving this thing, it will be easier for us to sort this cost based on the heights in an increment order. Otherwise, like how can I say that? Otherwise, if I have in a different order, then every time I need to handle whether am I decreasing, am I increasing the heights. That will be a tedious task. Instead of this, we are just enhancing the problem. We are easing the problem by sorting the values based on sorting the cost based on the heights. So I'll be considering the pair vector of pairs, and n is the total elements in my array. Now I'll be appending all these things into my V. I is equals to 0, I less than n, I plus plus, V dot pushback of, I need to make the pairs. In C++ we can do it directly using this thing. You can note it somewhere so that it will be helpful to you later on when you are coding. Now I will be sorting the V vector. So basically, sort function, by default sort function handles in an ascending order. Now I will consider two vectors. One is going from left to right, and the other is going from right to left, which I am representing as left to right, L to R, and right to left is R to L, for a simplicity purpose. Now I am having a sum which is initialized to 0. Then I will be having a total that is initialized to V of 0 dot second. That is the first cost which I have encountered. Now I will be going from starting first index 1 till n. Now at each step I will be summing up with my existing value. Sum is equals to sum plus, what should I do? I should the total captures my total cost till now I have seen. So this is my total cost. Then I need to do the difference between the current height and the previous height, which is V of I dot first minus V of I minus 1 dot first. This is my sum. Now I need to store this sum in my array. Now every time I need to add the cost till I have seen till now. Similarly, I'll be doing the same thing from right to left also. I greater than equal to 0, I minus minus. And now I'll be summing it up. V of I plus 1 dot first minus V of I minus 1 V of I dot first. This will be my difference, and right to left of I is equals to sum, and I increment the total. Now we increment the total. Now I know that for if I am at the particular index, I know what is the left cost and what is the right cost. Now I am considering my answer, which is very high. I need to minimize this. So for int I is equals to 0, I less than n, I plus plus, answer is equals to minimum of, I need to minimize this answer, which is summation of left to right and right to left. Now I'll return this answer. Let's try compiling and running it. So the two test cases have passed. Let's try submitting this. Yeah, we have successfully passed all the test cases. The main crux of this problem is finding we need to get the idea of, we need at any particular point, at any particular index, we need to know what is the left cost of converting all the heights to the height which I am at that particular index, and what is the right cost of conversion of all the heights to the height which I am currently in the index. So once after getting that idea, then we need to go to the next step of how can I achieve that. That is simply prefix sum. You can say we are using prefix sum kind of functionality here, and we are able to calculating the sum till then, I mean the cost till the total cost occurred till then, and in the left side and the right side, and we are summing at the two costs. That will be the cost to convert all the remaining towers to the tower height which I am currently standing at. Now we will be going through what is the time complexity and space complexity. Time complexity, it will be order of n plus order of n for this one, order of n plus n for this one, and order of n for this one. So order of n plus order of n plus order of n, which is order of 3n, which boils down to order of n. Now we will be going through space complexity. Space complexity, here I have initialized two arrays. I have initialized three arrays. One is vector pair, three vectors, pair of int which is of size n, and left to right vector and right to left vector. So basically order of 3n space which boils down to order of n space complexity. And if you see further, like if you notice, can I do it? Can I improve? Can I do the space optimization? Yes, we can do the space optimization. How can we achieve the space optimization? I can remove this L to R of n comma 0, because that I can incalculate that in this vector itself, and I can remove R2L of n comma 0. So how can we do it? First of all, we will be capturing all the total sum till R2L of n comma 0 from back to front, and I'll be capturing that in the sum variable sum. Now when I am going through first from this starting for int equals to I equals 0 to I less than and I plus plus, from starting onwards, then I'll decrement this sum and decrement this sum based on the heights and cost which I have seen. So that will give me R2L of at every index. Similarly, I'll increment this L2R. For L2R, I'll be creating another variable and I'll be incrementing that at each index accordingly. That anyway we are handling it here. In such a way, I can reduce this L2R and R2L total two vectors. So, thank you.